Hi there, I'm Irene from CNNECST, a project which aims to automate the implementation of convolutional neural networks on FPGA. Today, with our sixth presentation, we intend to analyze our project from a more technical point of view, giving an idea of how the framework works. The framework allows to design and customize a CNN by means of a web-based graphical user interface, using HTML5 and JavaScript to implement the client side and Python for the backend. In the following slides, we are going to present the different phases of the workflow. The application has a simple interface that can easily guide the user during the design process. As input, the framework only needs a file with the weights of the network that can be trained offline or randomly generated to test the feasibility and the performance of the hardware implementation. Then the workflow goes through different phases: the network configuration, the resources estimation and optimization, and the hardware generation. In the network configuration phase, the user has to provide the main structure of the CNN in terms of number of convolutional and linear layers. Then each layer can be customized by specifying the corresponding parameters, such as the number of filters and their dimension for convolutional layers. Once the configuration is completed, the framework is able to provide an estimation of the hardware resources that will be used by the CNN on the target device. In this phase, the user can modify the number of replicas of the CNN core to be implemented in order to parallelize the computation over the dataset. The model used to estimate the resource usages of the CNN on the specific device is based on the idea to provide to the user a resource estimation in terms of block RAMs, digital signal processors, lookup tables and flip-flops without the need to go through HLS phase. We have decided to identify a linear model for the resource utilization that uses the structural parameters of the CNN as input. Then we train the model of the data obtained from the synthesis of different CNNs to improve the accuracy. Here, on the right side, an example of usage estimation obtained with our web app. During the last phase, the hardware generation, the application automatically generates the C++ source code of the CNN and the TCL scripts needed by the Xilinx toolchain to generate the bitstream to configure the FPGA. Specifically, the application generates three different output files. cns.cpp contains the code description of the whole network. dir1.tcl is the directive file for Vivado HLS, and dir2.tcl the directive file for Vivado. The Xilinx toolchain uses all these files in different steps to generate the bitstream to configure the FPGA. The hardware template that will be implemented is composed of the specified number of CNN IP cores generated by means of high-level synthesis, the zinc processing system, and a DMA to send and receive data with the CNN cores. So, that's all. If you want now, you can try our web app at this link. Thank you for your attention, keep following us on Facebook and Twitter. Bye!